So very briefly, so my name is Pito. I'm a Hungarian ethnic, born in Romania, live and work in UK. I spent my entire life in software development, started as a programmer. I consider myself a practitioner. By that I mean I learn, practice in real battlefield techniques or ways of working, and I try to apply them and share them with the wider group. But what's more important actually is what I believe in. And I believe that we, humans, we are here on this planet to solve meaningful problems. An emphasis on meaningful. And throughout our history, again, we as humans, we have built tools to solve the challenges that we have faced. And one of the tools we have built is software and software development. But you see, building good software, it is hard. It is hard because it's part science, part engineering, part art. It requires conjoining engineering practices with agile ways of working. It requires finding a fine balance between building the right thing, building it well, and fast. And it requires people, passionate people. And this is where I sit. I sit at the intersection between engineering and agile ways of working, between software development and building and working with high-performance teams. And I'm here today to share some of my learnings. I come from one of the big four, which tend to have a bad reputation. But I'm hopefully here to demonstrate that actually we are not as bad as maybe some would portray. So, have you ever wondered why do projects fail? And I did. And I came to a conclusion that one of the reasons is because of a series of bad decisions. It's a decision of who to hire, what to build, how to release, and so on and so forth. We are under constant pressure to make decisions under the constraints of time and knowledge. We often do not know the answers, and we don't have the time to find one indefinitely either. Yet, we are seen having supernatural minds, possessing demonic powers of reasons, boundless knowledge, and all the time in the world to make these decisions. And this is how our manager sees us, our peers, our friends, and so on. And yet again, we do know that it's important to make decisions. So the question begs, how can we make good decisions fast? The idea of this talk stems from two real-life experiences that I had that led me to a path of research, reflection, and I found something, or at least I found something, and I'm here to share with you, and hope you find it useful. In terms of structure, very quickly, I'm going to talk about visions of rationality. I'm going to introduce the concept of heuristics. I'm going to talk very briefly about adaptive toolbox of heuristics, and I'm going to bring it at the end towards the agile and software development world, and hopefully we're going to have some departing thoughts. So we start with visions of rationality. According to Gurdjieff Gerenzi, Peter Todd, and the ABC Research Group, who wrote this quite nice book, Simple Heuristic Make Us Smart, they argue that rationality comes in two forms. The first splits separate models that assume that human mind has unlimited or supernatural reasoning power from the ones who operate with bounded rationality. Very, very quickly, bounded rationality and optimal constraint are decision-making strategies that have little or no regard to the constraints of time, knowledge, and computational capacity that real humans face. And they are traditionally modeled by probability theory. They talk about making decisions by surveying all the alternatives, listing all the consequences, computing probabilities and utilities, and making the calculations. But you see, this is not how humans think. Herbert Simon, a Nobel Prize-winning laureate in economics, he argues that models of human judgment and decision-making should be built on what we actually know about the mind capacities rather than some fictitious competencies. He goes on to say that because of mind limitations, humans must use approximate method to handle most tasks, and that includes the heuristics as well. So they've defined two types of bounded rationalities. One is satisficing, and satisficing is a method for making a decision, or making a choice rather, from a set of alternatives encountered sequentially when one does not know ahead of time about all the possibilities. This type of decision-making is relevant or is evident in the behavior of firefighters, who have to make life and death decisions very, very quickly. So the way they operate is then, rather than surveying all the alternatives, course of actions, they pick one, they play it quickly to a mental simulation, and if it's good enough, that is, it exceeds the predetermined aspirational level, they react, they act. Fast and frequent heuristics, so building on satisficing, they narrow the focus even more. They limit the search of objects or information using easily computable stopping rules, and they make the choices with easily computable decision rules. Let me take you a couple of examples. Oh, stop working. Okay, so consider the following. When somebody, when a patient is rushed to the A&E, the hospital, in the throes of a heart attack, up to 19 Qs are measured at admission. A doctor has to be very quickly decide whether the patient is at risk of heart attack or not. Common sense would dictate that the best way to do that is to take the results of all these measurements, combining them using some sophisticated probabilistic method, and make a decision. Consider instead this simple decision tree. It's simple because it has only asked 3 simple yes/no questions. It is fast because it doesn't require a lot of computation, and it is frugal because it uses only a subset of information found. Its simplicity, you would say that raises suspicion that it may be highly inaccurate. In fact, it has been determined it is a more accurate method than some complex statistical classification methods. Consider a game of chess. In a game of chess, there is an optimal best move exists at any given point in time. However, no strategy can calculate this move in a reasonable amount of time, despite its well-defined nature of possibilities to be searched. So Peter Todd and Gerd Renzi, they propose a move away from omniscient mind, computing intricate probabilities and utilities, to a bounded mind, reaching into a toolbox filled with fast and frugal heuristics. So very, very quickly, I'm going to take you through the definition of term heuristics, how it's been used through history. So with Greek origin, it means serving to find or discover. Early 1800s has been referred to be a useful, even indispensable, cognitive process for solving problems that cannot be solved through probability theory. In 1905, Albert Einstein wrote in a Nobel winning prize paper, he used the term heuristic to indicate that consider the view he presented within as incomplete, false even, but still useful. Oops. He went on saying that a heuristic is an approach to a problem that is necessarily incomplete given the knowledge available, and hence unavoidably false, but which is useful nonetheless for guiding thinking in appropriate directions. In 1920, term heuristic has been defined as a useful shortcut, as an approximation, as a rule of thumb for guiding search. Closer to modern times, Dave Snowden, creator of the Kinevin framework, he talks about heuristics as an ideal control mechanism under the constraints or conditions of uncertainty, and the general form is easy to understand. He often uses this heuristic in his talks. and it's a US Marine heuristics, and it talks about something lines of when the battlefield plan breaks down, capture the high ground, stay in touch, keep moving. This is a heuristic to ensure that soldiers on the battlefield have autonomy to respond quickly to changing conditions while remaining aligned with the stated commander's intention for the battlefield. And again, Dave Snowden would say that the compliance is easy to test and they handle uncertainty. To test compliance, all you have to ask yourself some yes-no questions. How we capture the high ground? Yes, no. How we stayed in touch? Yes, no. How we kept moving? Yes, no. It's easy to assess. Some very quick other examples outside the software field. Formula One, fast-paced cars are developing at a very, very fast pace. Adrian Newey, one of the all-times, arguably all-times F1 designer, he had a heuristic how to design an F1 car, and he says, continue to evolve the design of a car instead of always starting from scratch, unless it's clearly you're on a wrong track or regulation changing. Closer to software, Joel Spolsky, CEO of Stack Overflow, he says, don't rewrite code since you're throwing away real-world usage. You're throwing away knowledge. Solve coding issues instead by carefully moving code around, by refactoring. Martin Fowler says that the heuristic we follow is that whenever we feel the need to comment something, we write a method instead. So same as mechanic pulls the right tools to fix your car, in the same vein, we need to have the right tools, the right cognitive tools to make our decisions. And Agile, as a domain, requires its own adaptive toolbox of heuristics. And I'm going to take you through that. So the way we look into is we divide two sets of toolboxes, process heuristics, which is Agile and Lean toolbox, and technical practices, engineering practices toolbox. These are toolboxes that we equip our practitioner. We are not selling a method. We are just telling them, giving them these tool sets so that they can make decisions. So let me take you through them. So process heuristics. Discover iteratively, except that not all the work can, or I would argue even should be defined up front. Use an approach that allows for discovery work in an iterative fashion. And as Jeff Patton says, if you're doing it only once, you're not iterating. And this simple statement is extremely hard to embed. I struggle with our clients who are afraid of this. What do you mean you have to redo work? Yes, sometimes I have to redo what I've done before. Yeah, and you can discover it iteratively by having coherent ideas, by doing prototyping, by using real options mindset. Build multidisciplinary teams. Create teams around a well-defined work slice. Provide them with all the means necessary to complete their work. And by means it includes training, capacity, capability, tools, space, freedom, and so on. Create an environment of psychological safety. And I know that this might sound cheesy, but it's important that people feel safe. Unless they break the law, they should feel safe to experiment. They should be safe to find new ideas in their work. So in going back very quickly to compliance, it's easy to test. It's quite easy to test your heuristic. Are we discovering work in an iterative fashion? You'll know it, yes or no. How we build multidisciplinary teams, yes or no. Yes, so it's very easy. Heuristics are easy to test. Make sense of your world. As an opening talk is like the context is important. You will do different type of work that requires different ways of working. So this is the kidnapping framework that cannot be described in 30 seconds, but the takeaway is that when you do obvious work you've done before, then you apply best practice, because only one way to do that. Then you move the dial a bit to more complicated work, where there are multiple ways of doing it, where good practice can apply, which means that there isn't really a reason to fight if there are two good ways to fix a problem. But then you move in a complex world where actually you don't even know a priori what the solution might be. So the techniques that you use in obvious and complicated don't really work. So the idea would be that you, for each type of work, you kind of make sense where it is, and of course the type of work will transition from one domain to the other one, and you apply the right technique of work to depending on what you're doing. As Simon Wardley would say, execution alone is not enough. It's important, but not enough. A good strategy is important. Help visualize your context with techniques such as Wordley mappings. I would super highly recommend looking into Simon Wardley's work on Wordley mapping. I have used his techniques in less grandiose reasons than strategy. I've used it to understand the landscape that we're operating under, to come to better decisions such as how do we slice the work, how do we create the teams. Yeah, super, super interesting. And very easy to do, actually. Design work systems. Define a system to track and manage your work. Give a strong consideration to queue-based systems such as Kanban. I'm not saying use just Kanban, but give a good strong consideration. And the way you can do that is you can visualize your work, you limit work in progress, you can manage queues. Use an approach based on observation and measurement. Measure flow metrics, such as work in progress, cycle time, and throughput. Analyze them, understand what's happening in your work system under the hood, and then create new work policies to take into account what you have learned. Yeah, and you repeat this cycle. Use a forecasting approach to planning. What I actually mean by that is a big difference between a probabilistic outlook to planning and a deterministic one. A deterministic outlook, deterministic planning talks about providing one single date. I will be done with this piece of work on 20th of February. A probabilistic outlook is different. It's like the weather forecast. You provide a range of dates, each date backed by probability. You say, there's a chance that we can finish between February to March, and we have about 85% chance to finish in March. Perform short and long-term forecasts. Accepting the short-term forecast, like the weather forecast, is much more accurate than long-term one. And reforecast every time when you have new information. Set short feedback loops. So feedback loops enables learning, and you have a whole range of feedback loops. Pair programming is a form of feedback loop. I'm getting feedback in an instant on my code from a peer, as opposed to wait for pull requests or other ways of getting my feedback. Break releases in smaller chunks. Set each chunk as small as possible. Release it, learn from it, iterate. And use the feedback to evolve your solution. So it's a very high level. These are kind of the heuristics that we have created with ideas how you can implement them. Moving on to technical practices heuristics. So these are engineering practices toolbox. The way we see the world is that, as I said in my introduction, you can't say the ways of working or the process is more important than practices or technical practices. They're both equally important. A bit of disclosure before I move on. So we used to have our own kind of technical practices, but then this brilliant book came out, Accelerate, from Nicole Forsgren, Jess Humble, and Jen Kim. And we looked at it and said, actually, most of the stuff we talked about is in this book. So therefore, we adapted our practices, and most of them were adopted from this book. So a lot of what I'll talk about, you'll find in this book. It's a very small note. I see that covers the sources, so you can put them back on. Just I want to close out that on my slide that I do call out where I take inspiration from others' work. So version control everything. Use version control to control application code, configuration, system configurations. Yeah? Look at infrastructure as a code. It's a mindset. Automate deployments. I mean, I have a brilliant quote from down north. Automate when tasks become boring. Yeah? So fully automate deployments that do not require manual intervention. And look at the concept that I love is environments on demand. So if you want a new environment, as an example, you should be able to click a button, specify some parameters, go for a coffee, come back, and you should have the environment ready with the code you deployed already there. And that environment could be for performance testing, for security testing, or simply much smaller environment for your unit test. Integrate early and continuously. Yeah. Each code that you check in is a potentially shippable product. And the way I kind of visualize it is that kind of the value is in that cube, blue cube, and that's the commit. It's a potential shippable product. And as you progress that, you promote it through your quality checks, the more assurances you get, the more circles, concentric circles you add to that one, that could become a potential shippable product if you have met all your quality checks that you wanted. Avoid branches, use strong with development. I love the book that Nicole and Jean had created because that's based on DORA research, and they have found out that they can prove it, that trunk-based development is shown to be predictor of high performance in software and delivery team. And trunk-based development talks about having fewer than 3 active branches and forks that have very short lifespan and rare code logs. One of my projects, I wanted to encourage trunk-based development, and the way we done it, we said, is that any branch which is older than 2 days will be automatically deleted. Try it and see what happens. Automate tests. Use test automation. Man, it's quite clear. Is to sustain a high pace of delivery. Test early and test often and test well. Yeah? Maintain test data. Test data management becomes an ever-increasing aspect of software development. Your tests shouldn't be limited by lack of data. I work for high-profile clients whose lack of test data hinders the testing. If the testing is hindered, then your overall software development is hindered as well. Yeah? So make sure that you have data for tests. Shift left on security. This is taking InfoSec security roles and making as part of teams. This single element, I found it one of the hardest to realize in practice. I don't know exactly why just yet, but I found that getting security experts in the team, working with the team, a challenge. But I've seen the value of having it, where in essence you can test security as part of development, not as an afterthought. And finally, implement continuous delivery. And I'm going to go back to, again, to the book and the DORA research. There is continuous delivery is a practice that has been proven to be indicator of high performance. And this talks about prioritizing keeping the software in a deployable state or working on new features. And this is a constraint, and it will create some stress in the system. So what do you mean? I should work in a functionality to keep my software in deployable state versus building new feature? My suggestion answer is yes, it's much more important. Okay, so again, the toolbox. So this is kind of my rendition of what we do. In essence, we are equipping our practitioners with a starting point of toolbox. We give them these practices, these heuristics rather, and their process heuristics and engineering heuristics. And we encourage them to experiment. We encourage them to try new heuristics. By the way, not sure if this has stopped. Am I still on time? Good, okay, I thought that clock has stopped. So as a parting thought, so David talked about there's a difference between rules and heuristics. And I do believe there is, and I'm taking these definitions from Dave Snowden. And Dave Snowden says that rules, they set limit to actions. They contain all possible instances of actions. The principles, on the other hand, he argues that many actions can be justified by interpreting a principle. And a heuristic is a measure of guidance which can adapt to the unknowable unknowns. Ooh. And a heuristic, we know that sometimes it will work and sometimes it won't. But should it fail, we shouldn't be punished. So before I go, I wanted to kind of reflect what was this talk about. And I see it is a bit of agile, a bit of software development, and a bit of cognition. But what is cognition after all? And I found this brilliant quote in the book from Gergi Durenzi, which is, cognition is the art of focusing on relevant and deliberate ignoring the rest. And I believe we as a community, we have to pay more attention on cognition, on thinking, on how we make decisions, maybe than done before. So was this talk useful? Well, I'm going back to Einstein's quote, and where he says that the heuristic and this talk, I see it, is an approach to a problem, which may not be correct, but hopefully is useful nonetheless for guiding your thinking in some appropriate directions. That's all I had. These are some books and references I've used. Thank you very much for your time. Thank you.